All right, welcome to lesson 2.1.5. How can I model the data? This particular section has to deal with something that I like to call quadratic regression, because that's basically what it is, but those are big terms and you haven't learned that yet. But basically what it is, you're going to place this diagram using the e-tool, and you're going to figure out some information from that diagram that's going to help you plug that into the calculator to come up with an equation. But you can also kind of get close to the equation just using the e-tool that Desmos has in the CPM book. So part A, it says, what is the shape of the path of the Jackrabbit? Most of you are probably looking at that and realizing, oh, it's a quadratic. So we're going to come up with a quadratic equation. Some might say it's half a circle too, which is true, but you're really not going to go around in a circle, hitting the ground, going under the ground with those jackrabbits. This is just jackrabbits jumping over, looks like a fence. All right. With your team, find a strategy. So you're going to, in class, you'd find a strategy to find also the exact value of A. So we're going to go through that a little bit, but we're trying to get exact too. So what we'll do is we'll get as close as we possibly can with an equation in Desmos, but then I'm also going to show you an exact way to find it using your Texas Instrument calculator, which is really going to be important. What are the domain and range for this model? So we will figure that out once we get our equation going. And in your class, if you did this in your class, you probably talked and got numerous equations. Down below, it says, what are the discussion points? How can we fit this graph? How can we make a graph fit this situation? Well, we're going to do that. And what information do we need in order to find an equation? And how can we be sure that our equation fits the situation? Those are all things we're going to figure out working with this e-tool as well as the Texas Instrument calculator. So I am going to move on to the next slide so that we can get busy on this. Thanks. All right, so this is 2-65's student e-tool with our jumping jackrabbits. And so you can see here it's given us a slider of H, and it's given us a vertical K slider as well. And the H, by the way, is horizontal. So I want to move that slider so that I get this diagram over so that the fence is on the y-axis and this ground level is on the x-axis. So I'm just going to move this, and so I'm pretty sure I want H to be 0. So I'm going to go ahead and do that because I don't want any shift. All right, so it's at 0, and you can see how it's lined up there. But then I want the top of the fence to be at 3 because of this 3 feet. So I'm going to change that to 3. And now it's perfectly placed for me. So now I can play with adding equations in. So I'm going to use the graphing form of the equation using the 0 and the 3. And we're going to start. We don't know what A looks like. We don't know what direction yet to go. I'm just going to type in the H and the K right now with my equations. So we're going to say y equals, and it's going to be x minus 0. I'm just putting 0 in there because who knows, we might have to change it. We don't need 0 in the long run. But then I'm going to say plus 3. All right, cool. So I do have the vertex where it needs to be, but it's going in the wrong direction. So if you remember, if we want it, right now it's opening up. What we want it to do is point down. So I'm going to change this to a negative. Very good. So right now we have the vertex at the right place and it's pointing down, but it's not wide enough. So to me, I don't want it skinnier because that's a vertical stretch. I want it wider. So that's a vertical compression. So I'm going to mess with what A should be. And since we know that the absolute value of A, if it's greater than 1, is going to be a stretch. If it's less than 1, it's going to be a compression, and we want a compression. So I'm going to start with just changing it to 1/2. All right, well, 1/2's getting me closer and closer, but not close enough. So let's try 4, 1/4. All right, I'm getting closer. I still think I can go a little bit farther. So I'm going to try 1/5. Or 1/5. Ooh, gosh, I did 1/41/5. That's not what I want. I just want to change this to 5. Okay, very good. All right, so I'm getting closer and closer, but I still don't think that's exact. Because if I come over here, yeah, I'm at negative 3.873 and 3.873. So I might need a little bit different of a fraction to get to the points that I want. But what I'm going to do right now is I'm going to go ahead and show you a Texas Instrument calculator way to calculate quadratic regression, because that is the calculator that you would have. But first, I want to get some points that I need. All right, I am looking for this to be at negative, so I'm going to create my own little table. Okay, and let's start just by plotting a point. So -4, 0. And we know that's correct because it said it's 8 feet. the whole length. So there's one. Now I'm going to go up here and I'm going to create a table to go with it. Okay, and then I'm going to put 4, 0. And then we want our height, our maximum, our vertex, which is 0, 3. All right, so that's the table that I'm going to take to the Texas Instrument calculator and show you. And then we'll come back and address this a little bit more. Okay, so we are now continuing this on from 2-65. So if you're just joining us and this is a separate video link, I'm showing briefly how to do the quadratic regression for a certain scenario. And so in this case, we have a set of points that we want to use. And so what I'm going to go ahead and do is I'm going to show you how to access setting up those lists. So the first thing you're going to do is hit Stat. And then you want to edit this list, okay? So I want to edit 1, but I'm going to put a list of my X's and a list of my Y's. So in list 1, I want -4. And again, this is for a specific scenario. And then I want 4. And so, because basically what I have here are the zeros and the vertex. And so I'm going to use those to find my equation. All right, now I'm going to scroll over to list 2. And now I want 0, 0, and then 3. So that means my vertex is at 0, 3. And it is pointing down, which you can't tell from this particular equation, but we're going to go ahead and work on this right now. So what I'm going to do is I'm going to go ahead and hit Stat again, Calc. So I'm going to scroll to Calc. I know I have a quadratic, so I'm going to go to 5 so I can do quadratic regression. I have my list 1, and this is the default, so you're not having to worry about this. If you had multiple lists, you could go back and change it and put it in here in different lists, like list 3 and 4, whatever you want to do. But our X list is already put in list 1. Our Y list is already put in list 2. And so now I just want to go down and calculate. So I'm going to scroll down and calculate, and it's going to come up with the A, B, and C that I need for this equation. There we go. So we have Y, and then our A is going to be a -0.1875, plus our B, which is 0, so 0 times X, plus 3, okay? That is the quadratic equation you would come up with. And so let's go plug that in. And I'm going to go ahead and put -0.1875 X squared. I don't have a B, but I'm going to go ahead and just put it in here. 0 times X. Okay, that's not going to do anything. But then our C value was plus 3. Okay, so let's take a look at our graph. That is exactly what we're looking for. It crosses at the -4 and the 4. So that is our equation. Okay. Now I also, this is going to help when I go back to what I'm talking about in this particular exercise. Because I have this equation, I know what my A value is, and that's important for what I'm going to do next. But for those of you watching it purely for quadratic regression, that is how you find a quadratic equation, by having a minimum of 3 points to put into your Texas Instrument calculator. All right, moving on. Okay, so this video is just a finishing up of 2-65. We did a Desmos video that took us to this point, and then you'll see there was also, hopefully you watched the Texas Instrument 1, 2, so you can learn how to do quadratic regression in that calculator. And again, quadratic regression is when you give points to the calculator and you determine what kind of equation you need, and it spits back an equation for you. So on this one, our goal was to try to get closer than -1/5. That's why I did it on the TI. Plus, also, it's a very valuable tool, and it's important that you know how to do it. Well, we figured that out, and it was a -0.1875, and we'll talk about the fraction of that too in just a moment. So I'm just going to go ahead and type it in and see. Well, first what I want to do is this. Okay, this is how close we got, but we want it exact. So I'm going to put 0.1875, then X plus 0, and squared, and plus 3. Okay. All right. So I'm going to mute this green one, And I want you to notice how exact this particular equation is, which is perfect. Negative 1.875 is also the same as negative 3/16. So let's put that in. And there you go. So you have the fraction form of that as well. And that ends 2-65. Well, actually, there's one more thing we need to talk about. What is the domain and range for this one? Hopefully you are realizing that the domain for all quadratics is all real numbers. So from negative infinity to positive infinity. The range on this one is from negative infinity up to positive 3 because that's the maximum of our parabola. If you were also looking for what the axis of symmetry here is, it would be at the x or the y-axis, so it'd be x equals 0. So hopefully that helps. This is all 2-65. We're going to do a couple more in this lesson that are similar, but this one had a lot of pieces to it. So moving on. So this is 2-66. When Miss Bibby kicked a soccer ball, it traveled a horizontal distance of 100 feet and reached a height of 100 feet at its highest point. You'll also hear that when I show you the video on Desmos that we did. So there's a few points here that are really important to get on this graph. So I'm going to go ahead and draw them on here. And let me get a color we can see. Okay. So first of all, I have the little soccer player over here. So 75 feet is here. So that is negative 75, 0. Okay. And then we also need to hit 75 here. Okay. And so then we also have a max of 100. All right. And so basically what's going to happen is we want our graph to come all the way up here and then all the way down here. Forgive my drawing. That looks horrible. But anyway, that's what we're looking at. And so I've sketched a path, which is really scary looking. But now I'm going to show you a Desmos video that actually works through that. So it's a little more accurate. And then we'll give you the equation from the Texas Instrument video as well. Here we go. Okay, so we just talked about the diagram that I have posted in the slide. And I thought it would be better if I went through all of my trial and error on this one as well. So this is 2-66. And so it says when Miss Bibby kicked a soccer ball, it traveled a horizontal distance of 150 feet and reached a height of 100 feet. And it's at its highest point. Sketch the path of the soccer ball and find an equation of the parabola that models it. And you could sketch that all on your own. But what I did is I went to Desmos. And I created a graph that has the scale by using these tools here. I wanted to make sure it covered my maximum, which is 100 feet, based on the equation saying it at its highest point. And then I wanted to make sure I had enough room so you could see 150 split in half, which is negative 75 to positive 75. All right. So I have the standard form of the equation here. I do have a set at a -1, okay? And then I have the horizontal set at 0 because we're using the y-axis as our axis of symmetry. And then I have my k, which is 100. So the a is the thing that we have to figure out. Now, given that this is our a term, it means we need a vertical compression to widen it out to where it goes out to about here, which is negative 75. And so what I'm going to go ahead and do is I'm going to start changing the a fraction-wise. So what I want to do, instead of playing with the sliders, so I could do this and play with the sliders and see what happens when I go between 1 and 0. You see it getting wider, but it happens really fast because once I hit 0, it's flat. Okay, so I'm going to go ahead and put in the equation based on the vertex we have. And so I also know it needs to be a negative. So I'm going to put a negative. And then I'm going to come in here and change this h to a 0. Remember, you don't need that 0 in the long run. And I'm going to make this equal to 100, which we already have. Okay, so there's that. And so now what I want to do, I'm going to go ahead and get rid of these sliders for right now. Okay. And then we're going to play with a fraction in here. So I'm going to go ahead and just put 1/2 and see what happens. Well, you can see that widens it, but it's not even close to enough. So I think it's going to have to go a lot farther. So I'm going to start with 1/25. That gets it closer and closer. I'm going to go to 1/50. 1/50 is getting me really close. Let's see what 1/60 does. 1 over 60 takes me a little bit too far. So I'm going to go ahead and put in 1 over 55. That looks almost exact. In fact, look at this, negative 74.62. So I'm going to go ahead and put this video into the slide, but then I'm going to put another one in really quickly showing you again on the Texas Instrument how you can find it for this specific scenario. And then you will have that equation and I'll write it down on the slide, but you are good. This is all you need to know on this particular. We got as close as we could with 1 over 55. Let's now go see what we can do in that and the TI. Okay, this is 2-66, and again, we're going to use quadratic regression to come up with the equation that you need for this particular problem. And we've already figured out what we need in our list. We have our 3 points. We've talked about that. So let's just jump into it. I'm going to go ahead and stat and 1 because that's where I want to edit my list. So my x values for this table are negative 75, because remember we're doing half of 150, and then a positive 75. And then for our vertex, it's going to be 0 for the x. Okay, then we're going to scroll over, and obviously the negative 75 and 75 are our zeros. So our y value on those will be 0, 0, and then our maximum is 100 feet. So we'll have 100 feet that goes with the vertex. All right, that gives us the tables we need. And now what we're going to do is what we did before. We're going to go to Stat, Calc. We're going to go over to the Calc, and then we're going to hit 5 because we're looking for quadratic regression. And we're going to go down to, so list 1 and list 2 are appropriate. Going to go down to calculate, hit calculate, and it tells us what our A is. Look at that A. That's like a crazy A. That's going to be one that I write down before I put it back into the equation. So let's just go and see what that looks like on our graph. And I'm going to go ahead. I've got to clear this equation. That's from a previous problem. So negative 0.0, and then it was 1. Wow. How many sevens is that? That was 6 sevens. So 7, 7, 7, 7, 7, 7, 8. Looks like it was rounded. All right, x squared. Okay. Then it is, okay, we don't need to put a bx in there because the b was 0. So we're just going to say plus 100. And then we're going to graph it. And our window on this is not going to be good enough to see it. So we're going to change our window. Remember our x was negative 75 to 75. So we're just going to go ahead and say negative 100 for our min. Our x max will be 100. We'll choose a scale of 10. And then we're going to go down to our y. Well, our y min could stay at negative 10 because we don't really need anything below the x-axis. But we do need to make sure we can see the y max. So then what I'm going to go ahead and do is hit graph. And you can see where the equation goes. So this is 10, 20, 30, 40, 50, 60, 75. So that's negative 75. So if I use the trace button, which I'll do that for now, takes us down to our negative 75. Okay, and then if I go all the way around to the other side, stopping at the vertex, which is the maximum, we have our 0, 100. And then all the way down to, I don't know if it'll hit it perfectly, but it's really at 75. So that is the perfect equation for this particular scenario. And I will write that on the slide. Okay, so we just found the crazy fraction that we would put in for the A on this particular one on the TI. So let's go ahead and plug it in. And it is negative 0.017777778. Okay, then we have x, and we don't need, well, we'll put the 0 in there, plus 0 for now, but you don't really need it. It's just to help you remember what the vertex is. And then we have plus 100. So, all right. And now you see how close they came. Let's mute the blue. We were just off a little bit. So I wonder if changing this to 157 would have helped. Looks like it might be perfect. So just as a further exploration, I wanted to show you a tool that you can put into the calculator as well. And we'll just see if this can convert it to a fraction, that we know that it's a rational number, but I have a feeling it's not. But we're going to go ahead and go negative, because I just want to see how close our 1 over 55 and 57 were. So negative 0.01, and then 7777778. You can hit the math button, and you can hit 1 because of fractions and see if it will turn it into a fraction. Okay, it's not doing that. So we know that that's an irrational number. So I'm going to go ahead and just type in our 1 over 55 and see how close it is to our actual A value that we came up with. That's pretty darn close. Let's try 1 over 57. I'll bet it's closer. And we type that in, it's 0.0175. So it just shows you that, well, let's try 156. 1 divided by 56. All right, that's even closer. So see how close all of those are. If I was to put any of those values into the equation, it would definitely be very close. But this is the equation that we got on our quadratic regression, and that will end this one. I will also write the full equation on the slide just so people have it to look back at. And here we go. So now with everything that I've shown you in this particular problem, let's just go ahead and write out the equation. When we did the fraction, remember we came up with y equals, and it's a negative, and I'd say 1 over 56 was probably the closest. And then it's x minus 0, because our x doesn't move. There's no horizontal shift. And again, you don't need that 0. It's just helping cement the concepts of the vertex form, the graphing form of this equation, plus 100, okay? And then when we did the TI regression, remember it ended up becoming down to this exact point, 0, 1, 777, 7778. I think that's 6 sevens, yep. X squared plus 100, because B equaled 0 on that quadratic regression. And hopefully this video helps. Again, lots of stuff in these two concepts, 265 and 266, and on we go. So for this problem, which is the last one before you head into the review and preview, it's a skateboard park image, which you'll see I've put here together. The hot new attraction is the U-dip, a cement structure embedded into the ground. The cross-sectional view of the U-dip is a parabola that dips 15 feet below the ground, and the width at ground level at its widest part is 40 feet across. So if you take a look at what I drew here, I wish I could say I drew that. I didn't draw it. I just copied it on. We have a few points that we're going to go and do the quadratic regression for on the TI, but let's get those points written down. So first we have, this is negative 20, 0. Okay. Then we have 20, 0. And then we have our minimum, which is at 0, negative 15. So these are the points that I'm going to use on the quadratic regression. So let's take a look at that video. Okay, so this is our last, this is 2-67, and I've already shown you the drawing and the key points that we need to put in. And instead of doing a full Desmos video, I'm just doing the equation for the quadratic regression. So let's go back, start at stat, hit enter for the 1, and we have 3 key points that we need to put in. So we're going to put 20, and then negative 20, and then negative, no, 0, sorry. Then we're going to move over and do the list 2, okay? So that is 0, enter, and then 0, and then we have a negative 15, okay? We've done this a couple times, so let's now go ahead and hit stat, calc, looking for quadratic regression, 5, hit enter, enter, and enter, so we get down to calculate, and then we hit enter again for calculate, and we get the equation. So our A is a 0.0375, and we have a B of 0 again, because again, we're on the y-axis, so we're not going to have one. And then we have a C that equals negative 15. So let's plug that into the calculator and see what it looks like. And then we may have to adjust the window just to make sure we can see it all. But let's go ahead and plug it in. So 0.0375 x squared. And then it's just minus 15 because we didn't have a b. So minus 15. Let's take a look at the graph and see if we have enough to look at it. All right, I think I'm going to change it a little bit. All right, let's look at our windows. This is something you should get used to. So I'm going to put a negative 25 on the y min. And then on the y max, because we really don't need much, I'm going to go ahead and put 25, okay? I'm going to change the scale to 5. And same on... We're only going to 20 and negative 20, so let's make the window ideal. So let's put negative 30 as our x min and 30 as our x max, and then hit 5 for the scale. And then let's just hit graph and see what it looks like. There you go. There's your negative 5, 10, 20, 15, 20, and then 5, 10, 15, 20. And then we're down at negative 15. And again, you can trace that. You can go ahead and check it, see how it starts at the vertex. If I go to the left, okay, gives me negative 20, 0. And I'm going to go to the right, and it gives me 20, 0. So there's your equation up top, and we'll go back and write that equation on the slide so you see it. And that's it. So after watching the TI video, we now have an equation which I will write in vertex form. And it's a positive a, 0.0375, times x minus 0. And I'm only putting the 0 in because that is the value for our x in our vertex, and squared, and then minus 15. Now, the other thing, 0.0375, if you did the calculator, if you used the TI and did the fraction button the way I taught you, you would also get 3/80 as the fraction if you were to put that in instead of 0.0375. So that ends 2-67, but it also ends this lesson. And so if you have any questions, please leave notes for me in the comments below. Also, please give us a thumbs up if you enjoyed the video, and consider subscribing, and then you will get all of the videos in the future. And I wish you the best, and we'll see you on the next video.